All right, this is Mr. Ferguson,
Mr. Hunter.
and we're going to do the third, I guess, in our series of lessons on ionic nomenclature. So we've covered the basics, and then we talked about naming with polyatomic ions. So what are we going to get into in this one, Mr. Hunter?
We are, of course, doing more naming, but this time we're going to name ionic compounds containing those pesky transition metals, which have more than one possible charge.
And then after we learn to name them and kind of recognize they can have more than one charge, we'll learn to work backwards to determine the charges on the ion and then name the compound kind of in reverse. So let's get to it. This is just adding on to kind of the same basic ionic naming rules. I think you'll pick it up quickly. Okay, so when we look at the transition metals, there are 8 of them that can have more than one. That is 2 or sometimes 3, 4, even 5 possible ionic charges. So we have them listed there: cobalt, chromium, copper, iron, manganese, mercury, and then the last 2 really aren't technically transition metals, but they do have multiple charges also, tin and lead.
Yep.
So
for example, iron can be Fe3+, called iron 3, and it can also be iron 2+, called iron 2.
So really the only difference from that standpoint is when you name the compound, you just need to insert that Roman numeral after the name to recognize which form of iron it is. Because if we just said iron oxide, we don't know whether we're talking about the iron with the +2 charge or the iron with the +3 charge. So you've got to specify in the name, and then you're telling someone which charge that it has.
Okay.
So we have some example problems. Why don't you talk us through one of those, Mr. Hunter?
All right, so the first one we're looking at FeCl3, and if you are lost and not knowing what to do, we always say you should probably start with the reverse crisscross method if you need to. So you reverse what's there, so the 3 goes up for iron, so we find out that we have iron 3+, and then it's chloride because chloride is always -1. So there we go. So that's iron 3 chloride if you were to write this out. The next one is MnBr7. We apply the same logic. This time we have 7 bromides. They're all -1s, and that makes it manganese 7 bromide. So there we have it.
That says manganese, right?
Yeah, close enough.
7 VII. Bromide.
Yeah. And then the next one is the last one of that group. It's Cr2O3. And this one, again, you can do the reverse crisscross, and you'll find it is chromium
+3.
+3. -3 chromium.
O -2.
So it's chromium 3 oxide.
Chromium 3 oxide. All right, so the only difference is we need to insert that Roman numeral again, recognizing that there's more than one possibility for the charge. So let's go to the reverse kind of problem on the next slide.
All right, so the reverse method here is now we have iron 3 sulfide. We know that the Roman numeral 3 means it has a charge of +3, so it's Fe3+. Sulfide, using the periodic table, says it has a -2 charge. Okay, and then you crisscross these to get Fe2S3. Fe2S3.
Then, once you get to the point where you know what the charge is, then it's just like every other crisscross problem.
All right, next is copper 2 hydroxide. So that's Cu+2 hydroxide is one of those polyatomics you have to learn. OH -1. Now, when you crisscross using a polyatomic, you have to keep in mind that the OH is an entire unit. So it's not CuOH2, it's Cu parenthesis OH2. That way you understand that you don't have 2 hydrogens in one oxygen, it is 2 hydroxyl groups. Very key
Okay.
thing to keep in
Good
mind.
point. We're gonna have to maybe do that on the next one as well.
Yes. And you don't ever change the subscripts on a polyatomic when you do these. So the next one is cobalt to nitrate. So cobalt is CO plus 2. Nitrate is another polyatomic. It is NO3 minus 1. So you
We'll crisscross them.
crisscross them, yep. So it becomes CO with an understood 1. You don't have to write the 1. Then parenthesis, NO3. Remember the 3 stays because it's part of the NO3. It then becomes NO3 2, meaning there are 2 nitrate groups, not 1. And that's how you do the reverse method for these.
Okay.
All right, so there are 2 transition metals that we're going to require you to know. The first one is iron. Iron can either be a +2 or a +3.
So that's going to be iron, Roman numeral 2, iron, Roman numeral 3.
And then, of course, copper can be either +1 or +2. Those are just ones we expect you to know.
And I guess, the thinking people are probably wondering, why in the heck do they form ions more than one way? And we're not going to get too deeply into it, but just understand these transition metals have electrons in the d sublevel. And a lot of it boils down to that half filling that d sublevel. So when you have 5 electrons in there, it can be stable at that half-filled level, or that half-filled configuration, or it can be stable by kind of dumping off all of them and dumping off the S subset. So there's like kind of several different stable configurations.
It can kind of play, mix and match.
Electron shuffling going on there. So, but not to, we might give you questions involving some of the other ones, but these are ones you should definitely recognize. There's iron 2 and 3, and there's copper 1 and 2. And then we might even delve into like the old school naming with the Latin suffixes.
Cuprous and cupric.
But not in this lesson, okay? So we'll stick to the more straightforward Roman numeral system here. So here's your post-video questions. So there's one we're going to have you write the formula for.
And then the other one you have to write the name for.
And both of them involve these pesky transition metals. So
Good
how
luck.
about it?